I'm John Smith. I'm the CTO of LiveAction. I'm going to be talking about the technologies behind LiveAction. So LiveAction has very unique capabilities, and I'm going to be talking about each one of these. But knowledge visualization is one of the things that makes us very unique. And we've been doing a lot of visualization over the years, and on the top right you'll see this picture of a savanna in Africa, for example. And the human being has evolved millions of years being able to do pattern analysis, and you can tell that there's food here, and there's probably water by the river, and you can probably have a shelter by the mountain. So by evolution, we're really good at visualizing, understanding things. So we want to leverage those capabilities, but there's certain principles that you want to do when you do visualization. So there's one aspect of data visualization and information visualization, based off of human ability to do cognitive analysis. And then there's knowledge visualization theories as well. And lastly, there's situational awareness theories. And I'll go into more detail of some of these as well. But I want to start off with Ethan's blog. So I read Ethan's blog, his New Year thoughts on start with documentation. So why documentation is important is the transfer of knowledge, right? The mental understanding of the network and how and where to resolve issues. And you see symptoms of not having good documentation, like relying on scraps of paper. But whether you use a visual diagram or a hand-drawn diagram, we saw this as the mental model that a tool should start off with. But the problem with these visuals and hand drawing is it's not interactive. You can't explore it. There's no correlation to live network data. And it's not always accurate, right? Once you draw it by hand, you're not going to keep it up. But we kind of realized that if you started off with the topology, that maps really well to the way network engineers think about their network. So it's really about the mental model, really understanding what should that mental model be. And you got to kind of balance the accuracy and fidelity of that mental model. You don't want to show too much detail, but you have to show enough so that it represents what you want. But you have to give it the ability to be able to interact with that model as well. So, the mental model is the representation of how we think about things, and it's based off of facts and experiences. But really, it's so critical that mental models shape how we think and what is key in complicated situations. But it really shapes how we approach problem solving. Like when you think about your network and you want to do load balancing and you want to put more on another load, you go back to your mental model to think, which link is better, or understanding what are the trade-offs. But it really shapes our behavior and actions. So we really believe in how the mental model should be done. And this is from DMTF, right? So CMDBs, they have a SIM model, and this is overly complex. If you try to draw all this out, nobody's going to understand what this is. So we took portions of this, took portions that are vendor neutral, but we simplified it to some of the key aspects that we should visualize. And the second part about it that we work on is Ensley situational awareness model. So this is actually used quite a bit in the military side. So when you're doing battle planning, it's like situational awareness, get the understanding, make the decision, and act on it. And the mental model actually plays a key part in understanding on all the different aspects of awareness, decision, and performance. But you have to do sense making. You have to have a model that you can interact with to do sense making that reinforces your mental model, but helps you with what decisions to make. And once you make the decision, was that the right decision? So we spent a lot of time on actually coming up with this user interface. So that's why we did a topology-based visualization. And to be honest with you, this thing is addictive. And like I told you about the staff sergeant that's 22 years, he spent hours and hours on this. And sometimes we had issues with not being able to save this topology, and we'll get yelled at. What the hell did you do to my topology? I mean, I spend hours and hours, and whenever you go to a customer site, they realize something they never realized about. And sometimes I don't like doing demos on their network because they'll just go off and start looking at things, and they'll start exploring, why the hell is that happening? And it's just hours and hours of time. But when they do that, they really understand their network a lot more than they did before they had the tool. But you could do things like VoIP call tracing all the way down to your phone. You could do things like multicast flow visualization, where the rendezvous points are. So it gives you a lot of interesting things. But you can also interact with this. So once you get down to a flow, you can say create an ACL on it because I want to do a PBR or policy-based routing, or I want to block it right there. You can interact and actually do things that are useful. But I'm not going to do the PBR demo, but sometimes it's really hard to do PBR and know if it actually worked. If you can actually just see it, it's like so much better than doing the command line, doing PBR, didn't work. But we did some experiment with the CSR, but this is net flow, application traffic across your virtual routers, and it gives you a good idea of how the application is getting routed. Look at it from the routing perspective. The green lines are actually the adjacencies that are forming, and then all the different route table entries. So you can see it from the routing perspective. You can see it from the IPSLA perspective, what the link qualities are. So using this topology view gives you all these different dimensions that helps you to understand the network better. And then you can do it from the quality of service aspect. So that's kind of why we started off with the topology, because it's the perfect mental model and to understand what's going on. But one of the aspects that we did was overlay flow on top of this topology, and it's actually pretty hard. Dealing with the sheer number of flows, how to connect these things, how do you merge these flows? Because if you have millions of flows, it doesn't make sense at all. But being able to search and filter this becomes important as well. So this is one of the earlier ones where we just showed everything, and it's like, what the hell is that? A lot of people send in, screenshots of their stuff because it looks cool. It looks almost like art. But it's just interesting. But this is really what your network looks like if you don't, merge and sort this stuff. This is one where I think we're combining like a couple hundred, remote sites. So yeah, it's an MPLS cloud, but really you're connecting like, 100 sites. It kind of looks like that. And this is like when you have a ton of endpoints. So, this is kind of useful, but you got to search and, group it in interesting ways. But it's fun to play with the tool because you see so much. And then you can zoom in, but, sometimes it gets overwhelming. But sometimes it's just really interesting. Okay, so that was a quick information about how we do knowledge visualization, and I'll demonstrate it, and I think you'll realize it's very different from all the other tools. And I think that's kind of what our customers like, is like they can interact with it and do stuff instead of just reports and charts. So the second part I'll talk about is big data from NetFlow. So to drive all that visualization, you need a really robust back end, and we see flow adoption just really taking off. Like everybody's deploying flow, whether it's flexible NetFlow, IPFix, Palo Alto does it, Riverbed does it. So I'm hoping that more and more people in industry do it, because I think we kind of have to get off of SNMP. There's sample NetFlow and traditional NetFlow. But the characteristics of big data from NetFlow is like there's so many sources. People can turn it on a lot of devices now. Endpoints can do NetFlow. You could do it on your routers, switches, vSwitches. But it's really about schema on read and not write, because you can produce any kind of template now. And then we have to be able to absorb it without really knowing what they're going to be sending. And there's option fields, and so it became a lot more complex. And just in comparison, the packet capture is like the hardest, right? It just line rate, you got to capture it on disk, and then you got to analyze it. So that's really, really hard. And you pay a lot of money for those packet brokers. But midway point is really flow, where you could get to like 1 million flows per second. It's structured. It's less so than line rate packets. And then lastly, there's like logs, which is like 10 to 100,000 events per second. So we're kind of in the middle range. So when we looked at big data from NetFlow, how are we going to store all this information? We started off with SQL, and that doesn't scale. So we went to NoSQL. So we did Cassandra for multiple years. So Cassandra is big data. You can put 50 nodes into this cluster, and it'll solve the problem. it'll absorb it. But there's issues with write performance, but the cluster management is what gets you. So if you want, if a customer wants on-prem deployment of a NetFlow solution with big data, it just doesn't work because somebody's got to actively manage that big data. So we kind of been doing a lot of research in time series, and we actually converted that time series for NetFlow use, and that's kind of what we decided was the best solution. So we gave up on the Cassandra solution and we did time series. And time series is kind of interesting. You can build time series on top of Hadoop and Cassandra if you wanted to, but you kind of want to use a native time series database. And this came out of things like optical astronomy. So these astronomers were actually dealing with big data before big data was kind of popular. So they were dealing with terabytes of data coming from their astronomical telescopes. And if you see some of the bandwidth coming off of these telescopes on the mountains back to their labs, it's huge. So they had to build something called a time series database to solve this. And we've been doing this not so much for NetFlow, but from the military side, doing time series database research. But we realized that it's really good for NetFlow because it's really write once. You never update this stuff, and it's only read only. So if you take some of those principles and build a time series for NetFlow, it actually works really, really well. And the best thing is it's simple management so that we could put it on-prem, and then our customers don't have to manage a big data backend for it. So through the testing, we realized we can ingest 1 to 3 million flows per second using our time series database. But the best thing is, compared to Cassandra, it took a 20-node Cassandra to match our time series database. So who wants to pay for 20 nodes in Amazon when you can do it on one node in your on-prem? But once we got this big data backend, it allowed us to do a lot of interesting things like the situational awareness, the visual path analysis. We got DVR capabilities. We store all this stuff raw, so that when you play it back, we give you all the raw flows. So if you want to go back 30 days and see exactly what happened, we can do that for you. And then we can do network search, and I'll demonstrate that as well. Any questions on the big data? Okay.
Aside from the Cassandra stuff, there's a difference between unstructured data and structured data.
Right.
The advantage I think you're taking advantage of is structured data.
Right. So
Flow is inherently structured data, not unstructured.
Right. So I think a lot of the solutions like Hadoop and Mahout and those types of technologies deal with text-based information. So, but yeah, with NetFlow, it's very structured.
Rigidly structured and easily parsed.
Right, and
and starts from a point and goes through to the end. It's not like a.
And it's perfect for time series.
Text data that's dropped from a marketing database where the fields could be. Yeah.
And it's perfectly defined. It has a name, it has a type, it has a length. So we can just store it pretty easily. So the last part of our technology I'll talk about is analytics and control. So this goes into a little bit about the SDN aspect as well, but our current interface is the CLI API. So we actually model the devices. We parse the running config, we build out a model of that in our Java server, and when we bring in a device, we actually audit the capabilities. So we know, can you do Ceph, can you do NBAR, can you do IPSLA? So before you actually try to deploy these, we'll actually tell you if you really can do it or not. And then we support iOS, iOS XE, NXOS. We don't do the XR or the ASA. So this is some of the challenges of doing this layer, and we want to spend more effort into it. But we also know there's these controllers that are coming that are going to actually do a lot of this. So we're kind of balancing how much to do in every new model that comes out, and also multi-vendor like Juniper, like you were asking. It's probably better for us to wait for a northbound API to do a lot of this work.
Did you say you do not do the ASA?
Yeah, so we can do NetFlow from the ASA, but we don't actually configure the ASA.
Okay.
Yeah.
Why not?
Well, it's not close to iOS, so we'd have to build another model of ASA. So
even the capabilities are different in regard.
Well, I understand that about the ASA. It's just you guys are incredibly Cisco focused,
right?
And then you just took the entire security line of the Cisco product and said we're not going to do any configuration on that. That's interesting to me.
Yeah. So a lot of our configuration is kind of more on the quality of service side, and people have asked us to do QoS on the ASA. So yeah, someday we'll do it. And let me just talk a little bit more about the future controllers. So I think when we talk about Cisco APIC, they might answer some of your questions about the ASA as well. So future controllers, we are focused on the enterprise campus, WAN and wired wireless. And we want to be application level, meaning high level abstraction of business level policies. That's kind of our goal. But we see monitoring, whether it's SDN, that, I think IPFix, NetFlow, SFlow, and REST are the key technologies. And SNMP is just hard. Like, it always seems to be the last thing that engineers put in. And there's always some kind of issue with the SNMP. And it's just really, at times, intensive on the the processors on the routers and switches.
It's also antiquated.
Yeah. So we're hoping that NetFlow IPFix becomes the future. We want to leverage the northbound APIs, but we realize that once you put a controller in, the southbound APIs kind of go away, right? You can't have two brains working on that router or switch. So we know that we can't do 1PK CLI, netconf, those if you know that a controller is going to be coming to replace that. So the controllers, it's really about traction. None of our customers are asking for integration to an SDN controller because we're more enterprise campus branch. But we see it coming. On the enterprise side, we see the Cisco APIC. So they announced this at Milan, Cisco Live Milan. So it actually works with traditional CLI 1PK approach to existing ISR G2s, ASRs. So it's actually pretty good. So if there's traction in that, we would actually interface through the Cisco APIC. I'm just curious, how many people have heard about the Cisco APIC? Oh yeah, pretty good. Interesting.
In this audience? Yeah, of course. Kind of a skewed sample.
Okay. So on the SDN side, it's like, is it Open Daylight, Cisco One, Contrail? So we're kind of waiting a little bit here on what the northbound API is.
Need to dive in.
Yeah.
It's only a matter of time.
Yeah. So we have Open Daylight running in our labs.
Yeah.
We looked at that, and we know it's going to integrate to OpenStack, and it's kind of interesting with OpenStack with the Neuron plugin. It's like 15 APIs talking to the network. So
well, there's a big lack of visualization tools. There's one project that's now getting kicked off within ODL specifically called Deluxe. If you guys could get in now,
right.
I think you can make some huge splashes.
Oh, really?
Either with that project or with maybe your own.
ODL is
Plexi's doing the same thing for their Affinity API.
ODL's the only one that matters.
Oh, really?
Yeah. The other ones will go away.
Because you'll prove that your way of visualizing the network is the right way because you've submitted that to the community, and then you say, hey, we can actually make this a reality with our software. We think that these ideas run best in our software.
Right.
That might be your argument, but you'll already have submitted it to the community for evaluation of that idea.
Okay, interesting.
Yeah, Cisco's already behind APIC and ODL, and that's going to be it. They're behind those two. If LiveAction gets involved with ODL, I'm right with what Matt was saying. We have an opportunity to contribute to the project with code that is very much needed in that visualization aspect.
Okay.
Yeah, don't wait.
The time is right.
There is a convergence. There's some suggestions that the convergence is around ODL. So NSX and ACI will converge on ODL.
Oh, really? Okay.
That's just personal observation, but that is the suggestion at this point in time.
Right, that's good information. Yeah, we're kind of wondering, is IPFix NetFlow the monitoring method for SDNs? So,
hard to tell.
Like overlay networks, I think IPFix, grabbing VXLAN VNIs kind of makes sense, but for SDN, not sure.
Well, so the open vSwitch does SFlow. Right. So you also have to consider that as well.
It's a little hard to tell whether it makes sense to monitor at the flow level, like to actually create your own flows to monitor what you want.
Right.
Or is it better to monitor the post state, like the actual state of the network by picking up IPFix or SFlow or NetFlow? Or is it better to monitor from the pre-flow state, from the pre-state, by monitoring what goes into the controller and monitoring stats from the controller?
Right.
Two quite different use cases, as you'll be aware.
Right.
And I guess you'll just have to think about what makes most sense. and maybe go to the community and ask, and an open community will give you loads of feedback.
Yeah, we'll take a look at the open daylight visualization. Yeah. So for analytics and control, today we do multi-layer path analysis, and I'll show that in the demonstration. Alerting and reporting, we do search and semantic tagging, so allowing you to emphasize which interfaces are when, being able to tag interfaces, for example. For feature analytics, it's about real-time analytics, complex event processing. We'll bolt on some open source products to do that portion. But what we want to do is semantic extraction. So we did research on things like ontologies, and it's interesting. Like if you can bring in a network and then be able to infer things, it's interesting in that you can infer design errors, for example, or understand what the behavior should be. But you got to know that this switch is acting as a distribution or a core or an access. This is a wireless access point. When you start understanding these things, you can infer a lot more. So that's some of the direction that we want to go to. And then eventually behavioral and predictive analytics. But we want to do it at the flow level, like really understand how these flows operate. Oh, so this is my quick slide on QoS monitoring for overlay networks. So somebody submitted a question about how do you do overlay network monitoring? So not that I have the answer to that, but right now we do QoS and flow monitoring from like the campus WAN perspective, right? So the CATs, the ISRs, we do some of the Nexus 7Ks and 5Ks. And for traditional overlays like DMVPN and GREs, yeah, we can show you that, and we can do quality of service on that as well. But for the data center overlays with VMware and Cisco's and the Microsoft VXLAN NVGRE solutions, we can monitor some of the physical QoS on the Nexus portion, but there's, as far as I know, no way to do VXLAN VNI matches on QoS. So I'm not really sure, unless you get like a Cisco 9K ACI that automatically figures out the application quality of service. I'm not really sure how you're going to do that. On the monitoring side, there is IPFix, and there is ID 351 that shows you the layer 2 segment, and you can grab VXLAN VNI. So we haven't added this to the tool, but we could, and then we can do search on particular VNI and be able to show you that across your physical infrastructure. So that seems to be maybe low-hanging fruit to do.